Welcome back as we continue to solve linear equations, but this time instead of two variables, we are going to up the game and solve a system of linear equations in three variables. Now this process can be a little lengthy and trying at times, so please be patient with yourself. At the end of this lesson, you should appreciate what an ordered triple solution implies and just what it looks like on a 3D figure. And hopefully you'll be real good at solving a system of three equations. Let's get started. Before we get started, I want to go back and recap an important skill that we're going to use a lot in our concept that we're dealing with today, and that is something we're familiar with in our solving a system of two equations. We had a goal, and our goal was to get the coefficients to be the same. That would be the number that's next to the variable, and we wanted to get the opposite signs. We're going to use that skill a lot, so let's keep it in mind because that allowed us to eliminate the y. And when we eliminate the y, then we're going to be able to go ahead and add or combine these two equations. The 5x equals 35, and then x equals 7. And of course, from there, we were able to go ahead and plug that 7 back to either equation and find our y. But the important thing I wanted to point out to you is the skill of getting the negative and the positive to exist and the coefficient to match. Let's keep that in mind. Just watch. Don't take any notes just yet. We'll have plenty of time to get down the steps to how to solve a system of three equations in the next couple slides, and we'll also do some more examples. But for right now, I think it would be best if you just watch and listen. So the goal in solving a system of three equations is to combine two equations at a time so we can get the three variables down to two variables. And the first thing I want to do is to analyze my system and decide for myself which variable is the easiest to eliminate. Now I'm going to go ahead and tell you that the y's are the easiest to eliminate because I have plus and minuses, and I also have coefficients of 1. I like coefficients of 1 because 1 is an easy number to multiply by. I'm going to label my equations 1, 2, and 3 for the sake of making things easier when it comes to being organized with my thoughts and for you to follow along with. So now, as I said, we're going to put two equations together at a time, and out of the 1, 2, and 3, I think 1 and 2 are the easiest to put together because they already have a positive and a negative, so it's going to make it easy for me to eliminate them. So let's rewrite the two that we decided to use, the 1 and the 2, and I think it's very important that you rewrite the equations down below, because if you take your time and go slow, you'll do a nice job of getting the equation solved without making mistakes. So here we go. When we've got those y's, we're going to cancel them and we combine the other two equations. So we have 6x plus 3z equals 9. I just added those together. And I'm going to put that yellow equation off to the right, and I'm going to use it a little bit later when I find another equation to put it with. So now I'm going to go back and look at my three equations and decide for myself what two equations I want to put together next. And my choices are I could put 1 and 3 or 2 and 3. I'm going to put the 2 and the 3 together because I like the fact that we have opposite signs. Now keep in mind, if you went ahead and said you would have picked 1 and 3, that's okay. It would still work. And you'll get to the same answer. So I've decided to go with 2 and 3. So again, I'm going to rewrite my equations. I did notice though that the only way I'm going to get these to cancel this time is I'm going to have to make that second equation cancel by multiplying by a 2. And I'll talk more about that in just a second. Let me finish writing my third equation, which is 3x minus 2y plus z equals 3. You see, I don't have a match here. And in order for me to get a match there, I'm going to have to go ahead and multiply by a 2 to get that to happen. So here I go. I'm going to multiply every single term by 2, and I'm going to get 4x plus 2y plus 4z equals 6. And rewriting the third equation, because it does not need any adjustments, the coefficient is 2, it's the opposite sign. I'm ready to go with that one. So I cancel, add these together, 4 and 3, 7x plus 5z equals 9. Now I'm going to take that blue equation, I'm going to bring it up here with the yellow one that I put off to the right. Now you should be familiar with this equation. It's a system of 2, and we are ready to go. We can solve. So I'm just going to finish this off and show you what happens. When I solve this, I'm going to go ahead. I'm going to eliminate the z's because I like working with lower numbers. So I'm going to need a 5 here and a negative 3 here. And so that gives me 30x plus 15z equals 45, negative 21x minus 15z equals negative 27. Putting these together, I get 9x equals 18, x equals 2. Since I have 3 variables, I'm going to have what's called an ordered triple. We'll talk more about that in a little bit. And so my ordered triple is going to mean that I'm going to have an x, a y, and now we've introduced a third dimension, and that is z. Make sure you present your ordered triple in order. What did I find just now? I found the x, so that's my first spot, and so that's the 2. Now I have to go back and find y and z. To do that, I'm going to take my 2, and I'm going to go up to either the blue or the yellow equation. I think I'm just going to go with the yellow. It's easy to do. If I just take that 6, put my 2 for the x in parentheses, and I'm going to be able to solve for z because I've got it down to one variable. Remember, you can always solve for an equation and get to a value if you only have one variable remaining. That's why we went through all this work. And so here we go, z equals a negative 1. So I'm going to be careful to put that in the third spot because z is the last spot in my ordered pair. And finally, I need to go back and find my y. Now to find the y, I have to go back to one of the 3 original white equations. It doesn't matter which one I go back to, so I'm going to go ahead and pick number 3. So 3 parentheses 2 minus 2y plus parentheses negative 1 equals 3. Solving for this, I'll get my 6 minus 2y minus 1 equals 3, and I have 5 minus 2y equals 3, negative 2y equals negative 2, y equals 1. So my ordered triple is 2, 1, negative 1. And that's what it takes to solve a system of 3 equations. Did you notice when I did that problem that I didn't get an ordered pair, but instead an ordered triple? That must mean instead of a 2-dimensional figure, I now have a 3-dimensional figure. And you can tell by my graph what's going on here. I now have an x, a y, and a z for my axes. And also, observe that no longer is the x going right and left. That is taking the place of y. And what's taking the place of y? Z. Z is now going up and down. We've never had a z before. And the x is going from the front to the back. So some changes there. But what has remained the same is we still present our ordered triple in alpha order. So x is first, y is second, and z is third. Now if you want to know what octant, yeah, that's right, instead of quadrants, it's octants now, that this point is in, just keep it simple. Quadrants were counterclockwise, 1, 2, 3, 4, and in the back are now the octants, 5, 6, 7, and 8. With that in mind, I wonder if you know what octant this point, negative 5, 3, 4, is in this ordered triple. We'll talk more about this tomorrow. If you have that answer, perhaps you'll receive some extra credit. Now that I've done a problem for you, you can see that it's quite involved, and having some notes and some steps to solving a system of 3 equations will be a great resource for you to have with you as you work through the problems in class. So make sure you get these down, because we will be looking to see that you've got all 6 steps. The first step is to analyze the equations by looking at the coefficients. Do you have positives and negatives? Do you have any coefficients of 1? These would make it easier for us to solve the system. Once you've chosen the variable that you would like to eliminate, pick any of the 2 equations and start the process of eliminating that variable. Put that equation off to the side and go to step 3, where you'll combine a different set of 2 original equations. You'll also make sure that you eliminate the same variable. This is very important. Now that you have 2 equations of 2 variables, you have the skills to solve this type of system. So go ahead and solve it. Find those 2 variables, the solutions for them, and plug them back into step 5, which is to plug them back into one of the original 3 equations. Doesn't matter which one you pick, just pick one that looks easy for you, and plug it back in, and you'll get your 3rd variable solved for. Now when you're all done, make sure you're careful to present your answer as an ordered triple. That means put it in alphabetical order. Order is important. Take your time to get these notes down, press the pause key, and we'll do another problem as soon as you're done. All right, example 1. Let's get this down in our notes. 3x plus 4y plus 2z equals 11. Second equation, 2x plus 3y minus z equals 4. My third equation, 5x plus 5y minus 3z equals negative 1. According to my notes, my first step is to analyze the equations and pick a variable that is easiest to solve for, and I think that would be the z's, because I have positives and negatives and coefficient of 1 on that second equation. So I've decided to eliminate the z's. I'm going to go ahead and label my first equation a 1, my second one 2, and then I have the 3. I'm going to start by eliminating 1 and 2 together, because I noticed that in my second equation, if I just multiply by a 2, I will eliminate the z's. So let's write these down, equations 1 and 2, and then I will show you how I go ahead and eliminate the first z by multiplying the second equation by a 2. I always put my multiplier on the back side so I don't forget to multiply that 4 right there on the end there. So 2 times 2x is 4x, 2 times 3y is 6y, and 2 times a negative 1 is a negative 2. And don't forget that 2 times 4, this is the one that we sometimes forget, that's going to be 8. I'm going to rewrite my first equation, which is 3x plus 4y minus 2z equals 11. So here you have it, that's my 2 and my 1. And now I'm going to go ahead and eliminate the z's. That was a plus in my equation 1. So negative 2z, positive 2z eliminates. And now I just combine, or just add, if you will. So 4x plus 3x is 7x. 6y plus 4y is 10y. And 8 plus 11 gives me 19. I'm going to take this equation and I'm going to put it off to the side. Up here on the right hand side, 7x plus 10y equals 19. Alright, now it's time for me to pick a different 2 equations. And I'm going to analyze this again and see that I think the best ones to eliminate would be 2 and 3, because then all I have to do is take that second equation and multiply that by a negative 3. So let's get started. Let's write our equations. Number 2, once again, is 2x plus 3y minus z equals 4. And my number 3 equation is the 5x plus 5y minus 3z equals negative 1. I'm going to take that second equation and multiply it by a negative 3. And that would give me, for my second equation, it will give me negative 6x, negative 9y, positive 3z, that's what I was looking to achieve, and a negative 12. I'm going to go ahead and just rewrite, well, you don't even have to rewrite that third equation. It's right in front of us. We can eliminate it right here. So we're working right within here. I'll box it off for you. And I add them together. 5x positive minus 6y gives me a negative x. 5y negative 9y gives me a negative 4y. The z's eliminated. And negative 1 plus a negative 12 is a negative 13. And there we have it. There's my second equation. That's awesome because now I have a system of 2 equations. And I know how to solve these. I'm simply going to take, I think I'm going to eliminate the x's and just multiply the second equation by a 7. So when I do that, I get 7 times a negative 1 is a negative 7x, negative 28y, and 7 times a negative 13 is a negative 91. I'm going to rewrite the yellow equation underneath it. It's a little too far away for me to see what I'm doing, so I don't want to make any careless errors, so rewriting it is worth taking the time to do. Now the x's have canceled, and I'm left with a negative 18y equals negative 72. Dividing both by negative 18, I'm winding things down here, and I found my y to be a positive 4. Now it's at this point that I find students sometimes get a little stumped on what to do. You're going to try to go back to one of the first 3 original equations. You're not going to be able to get an answer because you only have one variable solved for the y. So instead you have to take that y and bring it up to one of these two, either the yellow or the blue equation. I'm going to go ahead and do the blue equation. So I'm going to say negative x minus 4 parentheses equals negative 13. Remember, parentheses, parentheses. We put our subs in parentheses. There I go. I got a negative 16. I'm going to add that to both sides. And I get a negative x equals a positive 3. X equals negative 3. Now all I have to do is go back to one of the 3 original equations. I'm talking about one of these 3 up here. I'm going to go with the second one, and so I'm going to write 2 parentheses plus 3 parentheses minus z equals 4. I'm going to fill in those parentheses with the values I know. The x is negative 3. The y is 4. I found those when I solved my system of 2 equations. And I'll go ahead and simply finish this off. Negative 6 plus 12 minus z equals 4. I think you'll find it useful to put that extra line through the z so you don't think of it as a 2. That can be confusing at times. And so z equals a positive 2. Present your ordered triple as negative 3, 4, and 2. And that is your ordered triple. Alright, so here we go with example 2. Let's go ahead and do this one together. Remember to press that pause key if I'm going too fast for you, and work at your own pace. So I'm going to label these 1, 2, and 3. As I look and analyze, I see that they're either all positive or all negative on my variables. So I don't have any advantage to the plus or the minus. And as I look, they all have a 1 coefficient, so it really doesn't matter which one I pick. I'm going to go with the x's. as I look at my x's, I like using that third equation for both of them because that's going to give me that coefficient that's easy to work with. So I can already tell you I'm going to work with the 1 and 3, and I'm going to work with the 2 and the 3. So I've set my thinking up to what I want to do here, and now I can just continue by writing down the equations and working very slowly and carefully so that I don't make any mistakes. And now I'm ready to take my third equation here and multiply that one by a -3 so I can get those coefficients to match. And that would give me a -3x plus 9y minus 3z equals 6, bringing down my yellow equation from up above there, my number 1 that I started with. And now I've got my x's canceling, and that gives me 7y minus z equals 4. I'm going to write that up and off to the side. And now I'm going to go to my blue equations. I've decided to go with that 2. Remember that if I eliminate the x's in one equation, then when I go to, or one set of equations, when I do my second set of equations in blue here, I'm going to eliminate the x's as well. And so what do I need to multiply to get the x's to cancel? I'm going to need a -2. So I'm going to multiply that second equation, actually it's the number third equation, and I'm going to multiply that by a -2. And so -2x, positive 6y, -2z equals 4. Bringing down the blue equation, I can see now that my x's are going to eliminate, and I get 5y plus 2z equals 11. Put that up underneath the yellow one here. I now have a system of 2 equations. And I can see an easy way to solve this would be to multiply that yellow equation by a +2 to get 14y minus 2z equals 8. Cancel that out and I get 19y equals 19. It looks like y equals 1. I've got one part of my tripled ordered, and now I have to find the other 2. Going back to the yellow or the blue equation, I'm going to go ahead and plug that y in, and so 7 times 1 minus my z equals 4, and I found that I'm going to get z equals 3. I am almost done. Going back to one of the originals, I like number 3, and I'm going to find my x right now. So x minus 3, I know my y value is 1. My z value is going to be 3, and I always put my subs in parentheses to protect those signs. And so it looks like I have x equals a -2. So my triple ordered is going to be -2 is first, then the y is the second coordinate, 1, and my final coordinate is 3. And there we have our conclusion of example 2. We've worked through some problems together, and you're developing some skills on solving a system of 3 equations. And now it's time for you to take on a challenge all by yourself. Go ahead and use your notes. They are a wonderful resource with some steps that will help guide you through this system of 3 equations. Go ahead and give it a try. Press that pause key. Come on back when you're finished. Good luck. Well, welcome back. And now that you have your answer, let's see if it matches the one that I'm about to reveal. The ordered triple for this problem is -6 to 11. How'd you do? In our wrap-up, to solve a system of 3 variables, you're going to go ahead and reduce your 3 variables to 2 variables. Do this twice, and when you do, you'll have a system of 2 variables. Go ahead and solve that. When you want to find your third variable, now it's time to go back to your original equation and find that third variable. Remember, that's only after you found 2 of the 3. And then when you're all finished, don't forget to present your answer as an ordered triple.